Universidad del Desarrollo de Chile. He is going to talk to us about collective intelligence, and we'll be talking on topics such as the types of collective intelligence, tools for collective intelligence, and collective memory. So please join me in welcoming Cristian Candia and put in those questions. Thank you.
Thank you very much. So I'm going to share screen now. I'm probably going to ask you if everything looks good.
It's looking good.
Okay, perfect. So thank you very much for being here today. And thank you very much for the organizers for inviting me to this fantastic Wednesday at NICO sessions to share with you some of my ongoing research. I'm Cristian Candia. Since last January, I have been an assistant professor and the director of the master's degree in data science, not the institute in data science. Okay, so these are two different things. In Universidad de Chile, in Universidad del Desarrollo in Chile. Besides, I'm an external faculty at the Northwestern Institute of Complex Systems, and today I will talk about the digital footprints for collective intelligence. In early 2014, by the end of my physics master's degree, I was attracted to the naturalistic turn of the social sciences, particularly in the area of computational social science. Thus, I started my master's degree in social complexity and then a PhD on the same topic. This decision took me to Boston to finish my PhD research, and then in 2019 to here at NICO as a postdoctoral fellow. I would like to start this presentation with a famous Chilean story. In August 2010, 33 miners got trapped in more than 700 meters under the ground after the collapse of a mine in the north of Chile. Rapidly, most of the public attention turned into this accident. 3 separate drilling rig teams, nearly every Chilean government ministry, NASA, and a dozen of corporations from around the world cooperated in completing the rescue. After 69 days, the miners were rescued one at a time in an specially built capsule, where, as an estimated 5.3 million people worldwide watched the rescue via video streaming. This story illustrates some of the key aspects related to collective intelligence. First, the role of focusing an important part of the public attention in this accident. It catalyzed the collective effort where 3 teams of drilling experts, NASA, the Chilean government, and a dozen of corporations coordinated and cooperated, resulting in an expression of collective intelligence, the successful rescue of all miners. On the other hand, a classic example of collective intelligence are ants, insects that are individually very stupid, but in groups they can do quite smart things. In both examples, miners and ants, another key aspect of collective intelligence is the flow of information and the effective communication between individuals and all the involved parts. While in these 2 examples, mapping the flow of information and reconstruct the communication among individuals can be difficult, nowadays an important part of human interaction occurs in the digital sphere. The massive digitalization opens a whole new window to investigate human behavior. We can use the digital footprint that people leave behind using data science tools to answer old and new questions in the social science. There are different scales of collective intelligence. First one, we have the original collective intelligence, which consists of small groups composed of highly specialized individuals, such as wolves, dolphins, big cats, and humans. For instance, online multiplayer games or communities are another example of collective intelligence. Games such as Halo or Call of Duty rely on gamers coming together as a community to form the game's identity. Without shared rules, nor a system for collaboration, no one could play. This collaborative environment, the gaming ecosystem, is a prerequisite for competition. In other words, collaboration precedes and is a prerequisite for competition in games. Okay. Second one, we have pyramidal collective intelligence, which allowed human species to build large collectives via the leverage of centralized power and chains of command. Examples of this are armies, government, research labs, corporations, churches, among many, many others. And finally, we have a new form of collective intelligence has emerged thanks to the internet, appeared in early 2000s and have grown extremely fast. It is distributed, agile, based on leadership and the internet. It supersedes pyramidal collective intelligence, and we can already see its huge impact on humanity, where more and more people in civil society self-organize in order to address societal issues that pyramidal collective intelligence cannot address or even provoke. Here, for instance, Wikipedia is one of the best examples of collective intelligence. Anyone can add information to an existing page, or indeed create a new page of information. Pages also hyperlinks to other areas of the website that people have edited, right? Thus, we can improve our individual outcomes by using this distributed and agile collective intelligence system. Google is also a prominent example of collective intelligence. The search engine is made up of millions of websites, which have been created by people all over the world, making them available to the public. So we can design instruments and experiments to exploit the digital footprint left behind by people interacting in online communities, organizations, and distributed and non-local systems for understanding and improving collective intelligence. If a group of people can learn collectively and store what is learned in their collective memories, in the need to solve new problems, collective intelligence can be improved and even emerge. More formally, collective intelligence is defined as a shared or group intelligence that emerges from collaboration, collective efforts, and competition of people, and appears, for instance, in decision-making by consensus. It can be also understood as an emergent property between people and the ways of processing information. In the classic formulation, collective intelligence refers, for instance, to a situation where nobody knows everything, everyone knows something, and what any given member knows is accessible to any other member in a single query. According to the French philosopher Pierre Levy, collective intelligence aims to improve individual performance and mutual recognition, and in general terms, can be defined as the capacity of human collectives to engage in intellectual cooperation in order to create, innovate, and invent. Therefore, our research focus on three fundamental things for this goal of collective intelligence. First, we have tools for collective intelligence. Then we have the types of collective intelligence where we particularly focus on cooperation and coordination. And finally, the means or the essentials for collective intelligence, where we focus particularly in collective memory and attention. So in the tools for collective intelligence, I will start with two tools for collective intelligence and one research application of each of them. So let me begin with the higher education space. The higher education space is a network that connects degree programs given the applicants' preferences. In other words, we use the preferences of past applicants as a source of information for mapping the relationship among degree programs. For instance, if an applicant applies to medicine and pharmacy, we link these two degree programs. Then we do the same for all the preferences of each applicant to the higher education system in Chile between 2004 and 2020, resulting in a co-occurrence matrix where each entry defines the number of times in which two different degree programs were applied for together. Then we compute the strength of the relationships between degree programs by computing the phi correlation, where we only consider positive correlations. Next, we maintain all the links that are statistically significant using a simple t-test with a p-value of less than 0.05. And finally, we discarded all loose nodes, and note that also we replicate this network filtering process by using a bootstrapping strategy, obtaining exactly the same results. So all of these statistical steps translate into a similarity map of degree programs, where related degree programs are closer on this map. So the higher education space captures the knowledge distributed among all the previous applicants to the higher education system, making it available to the public in a single query. So for this goal, we are developing a website to deliver this distributed knowledge in a friendly way. Here, people can select the degree programs that they are interested in and then apply some geographical filters if needed. And then the platform will recommend you new related degree programs. Also, the platform will deliver relevant information for the decision-making process, such as the cost of the degree program, employability rate, expected income, retention rate, actual graduation time, and the minimum score of the last candidate in the previous year. Moreover, the platform will also recommend related technician level degree programs to explore. Also, applicants will have the chance to further explore specific degree programs, specific institutions, and even compare side by side different institutions. Thus, to make an informed decision on what degree program to choose. So they will improve their individual outcomes in the decision-making process. Finally, note that all the information and data included in this platform was validated with students, previous applicants, representatives of higher education institutions, policymakers, and the Chilean Ministry of Education. Well, yeah. One research application of this platform and this data, right, is related to university retention and dropout rates. In the OECD, 31% of enrolled students do not finish their higher education. In Chile, the story is similar. 28% of higher education students do not graduate. This corresponds to a 30% of the public spending in higher education. And these numbers translate to an opportunity cost of $2,600 million for the country. So academic performance, family income, and social support are associated with dropout rates and retention rates. However, little is known on the effects of making an informed decision on what degree program to enroll impacts degree program retention. To quantify the consistency and inconsistency of individual preferences, we use the higher education space. In simple terms, similar degree programs are closer on the map. So here we found that for students with a high score in the national exam who apply to close degree programs on this map, they have a first year retention rate close to an 80%. In comparison, students with the same scores in the national exams, but who apply to distant degree programs like these yellow dots here on the map, they have a first year retention rate close to a 53%. This implies that preparing a good exam is not enough to succeed in higher education. You also need to maximize the information that you have at the moment of making a decision. These results are robust to control for individual socioeconomic confounders, such as sex, age, family income, parents, education, among many, many others. Besides the proposed metrics, the distance of degree programs in individual application is one of the most important predictors of the first year retention, only after the enrolled score, the city of origin of the applicant, and the enrolled degree programs. Note that all this data comes from the Chilean Ministry of Education, and we replicate also our results with data from Portugal. Now, we move to elementary education with a second tool for collective intelligence. As we know, social relationships in humans has been a research topic for the last few decades, right? However, studying social relationships in children is difficult, and in a large-scale setting is especially challenging. The main difficulties are given by the biases that traditional instruments, such as surveys and sociograms, induce in young people. To tackle this limitation, we brought the lab to the field by using tablet computers like this one here, and then we built a website. We first developed a friendly video game based on game theory to capture social relationships and cooperative dispositions between elementary school students. In the video game, children face a dyadic and non-anonymous social dilemma, where they have to choose how many tokens sent to their peers between 0 and 10, and then these tokens are multiplied by 2. After each student plays with all their classmates, we are able to map the entire cooperative social network for each classroom. After collecting data for more than 1,400 children, we found 3 archetypical clusters: the social optimum, where both peers send all tokens; the non-cooperative or the Nash equilibrium of this game, where nobody sends anything; and the asymmetric outcome, where one takes all and the other takes nothing. So we created a website for gathering data and to deliver insights for cooperative learning in elementary schools. Teachers or school counselors can enroll their students in the website, and then students have to click in their names to start the experience. First, students have to reply simple questions related to their peers. For instance, who are the populars, with whom they like or dislike to play, among many others. Next, students have to reply questions related to them, such as if they have mocked any peer in the last few weeks, if they have started a fight, or if they have socially excluded other peers. After all the students finish answering the questions, they will play the social dilemma. Children have to move the number of tokens they want to share with their peers, and the tokens will multiply by 2. After each student plays with all their classmates, the game finishes, and children receive short feedback about their final outcomes. Finally, teachers and school counselors receive an automatic report about the cooperative dispositions in classroom, which they have found very useful for decision-making in elementary schools. One interesting research finding of this experiment is that high GPA children and low GPA children cooperate equally with their friends. However, high GPA children tend to be less cooperative with their non-friends compared with low GPA children. This difference, combined with that high GPA students are in general more involved in reciprocal relationships, translate into higher cooperation returns in both friendship categories for high GPA students. These results suggest that higher GPA children are more strategic in their cooperative decisions. So now, as in the Chilean minor example, cooperation and coordination are pivotal for collective intelligence. Here, we will talk about 3 projects about the types of collective intelligence. The first 2 are related with the tool for collective intelligence in elementary school. And the third one, it's about a constitutional making process that took place in Chile in 2016. So we have found that high GPA students get more investment returns from their friends and their non-friends compared to low GPA students. So here, using a difference in difference strategy and data from school records, we found that this premium on cooperative returns translate to an increasing in academic performance. Despite that, to cooperate has a negative effect on final GPA, the received cooperation and the reciprocity in a student's relationship have a positive effect on future academic performance. In practical words, if a student belongs to the 25% of the reciprocal relationships in their class, the future GPA increases by 1 point, which in this particular sample represent a 40% of change in the GPA between 2 consecutive semesters. This result holds after controlling for individual fixed effects. In this experiment, we also gathered data using peer nominations. Children had to nominate up to 5 other classmates in terms of their popularity, aggressivity, who they like or dislike to interact with, and who their friends are. Then, using the aggregated data on how students cooperate with each other, we built a social rank measure, operationalized as the PageRank network centrality, that gives importance to a given student in terms of how important are their connections in the classroom and the exclusivity of those relationships. Our social rank metric captures different features of students, such as popularity, like and dislike peers, aggressive children, class attendance, and academic grades. All of these relations are in line with the literature on social status. So we found that for peer interaction in the absence of friendship, we observe a linear and positive relationship between the difference in the social rank and the difference in the cooperation between both students. But in friendship relationships, we observe no effect of social rank on cooperation. Thus, the results suggest that friendship modulates hierarchical relationships in elementary schools. Coming back to the minors example, coordination is a key aspect for collective intelligence. So here, on a different matter, we study citizen participation in a bottom-up constitutional making process held in Chile in 2016. Here, people self-organize in groups of 10 or more to discuss about which social rights should be included in a new Chilean constitution, among many other things, right? Each group had to choose jointly 7 rights from a list of 55. Then they have to deliberate and write down a conclusion or an argument to include for each constitutional right. The case of Chile is remarkable because so far it is the largest volunteer deliberative process, covering 98% of the national territory, involving more than 200,000 participants in the whole process and more than 8,000 local deliberative instances. In terms of citizen engagement, one key feature for the Chilean success was that participants voluntarily decided whether to contribute to the debate or not in a series of local encounters. Yet, the inclusiveness of the process with an unequal representation of citizens is a challenge. So given that, we start by quantifying the determinants of citizen participation at the level of cities or comunas in Chile, and we found that population, the higher education rate, internet penetration rate, the number of community organizations were positively associated with citizen participation. Also, we found that ideology matters, as the rate of votes for the current president are positively associated to citizen participation. We also found spillovers of other types of political participation, such as party affiliation. Here. After understanding all of these determinants of volunteer citizen participation, we inspect the arguments provided by groups of people. To assess the quality of the argument text, we propose a metric with 2 categories. First, texts that offer only an assertion without adding any justification. For instance, we must preserve environment for future generation. These kind of texts are categorized as low quality arguments, okay? And second, texts that offer an assertion, but also justify the content with testimony or evidence of some kind are categorized as high quality arguments. For instance, it is very important to live in a pollution-free environment, and for that, we must promote respect for nature, both as citizens and businessmen. These kind of texts are all categorized as high-quality arguments. So, in general, good quality arguments are not ubiquitous across the different deliberative groups. Indeed, we found that cities or communes with higher socioeconomic development index produce higher quality arguments. These results suggest that coordination for collective action here created an argument on why social rights should be included in a new constitution, not always generate good outcomes. Therefore, deliberative instances should rely on strategic designs. So finally, the example of the Chilean miners had another key aspect. The focus of collective attention catalyzed collaborative efforts, resulting in outstanding outcomes. For instance, the rescue of the trapped miners. In this final part, I will show you some project that aims to understand collective attention dynamics. First, we take a novel approach fully grounded on the theoretical literature on collective memory that inspired a model for collective attention. Indeed, we developed a model for collective attention decay fully grounded on collective memory mechanisms. But what is collective memory? Collective memory can be defined as a shared representation of a common past created by a group of people. Therefore, it is subjective, and each community decides what and how to remember events, information, people, and cultural products. And it cannot be understood without considering the context where people and communities participate. Collective memory can be divided in two parts. First, communicative memory. That are all the memories sustained by socialization and verbalization of information, such as family stories, scientific conferences or webinars, or listen a new song in your favorite bar. And second, cultural memory. That are all the memories that are sustained by the access to records. For instance, looking for a paper in Google Scholar or for a biography of a famous athlete in the Wikipedia, or your favorite song in Spotify. So, inspired on these collective memory mechanisms, we propose a model for collective attention decay that, after controlling for preferential attachment effects, it depends on three parameters. The P parameters that quantify the attention decay from communicative memory to oblivion, Q, which quantifies the attention decay from cultural memory to oblivion, and R here, which quantifies the attention transition from communicative memory to cultural memory. We validated this model using data from scientific articles from the American Physical Society, patents from the United States Post-Trademark Office, songs from Spotify, Last.fm, and Billboard, movies from IMDb and YouTube, and finally, biographies of famous athletes from performance rankings and the Wikipedia. So after controlling for preferential attachment effects, our model explains the aggregated patterns of collective forgetting and outperforms previous literature models in these 5 different cultural domains. Our model also predicts an attention premium related to the increasing of the parameter R, and also a transition time where cultural memory takes over communicative memory related to these 3 parameters. Both have practical and real-world consequences and applications, as mentioned in a perspective article in Nature Human Behavior in 2019, understanding how one could delay the inflection point of the bi-exponential function, could offer policymakers much needed time to log in commitment devices at a population level. So first, we further explore the role of the attention premium on collective attention. We use the three model parameters, P, Q, and R, to build rate of forgetting for the entire system. We call it lambda. As before, after controlling for preferential attachment, where our model generates independent temporal vertical curves, like here, we found that as the number of documents grows, it also does the forgetting rate. We provide statistical evidence on these results using a two-way fixed effect and a difference in difference identification strategy. We found significant empirical evidence on that the excess of information promotes forgetting for different communities. Here, physicists, and here, inventors. Oh, okay. Something happened, sorry for that. Okay, so besides, these communities also increase the rate at which they store information in their cultural memory, quantified as the parameter R, which generates an attention premium for those documents. Moreover, results show that valuable records are significantly more accessed in both communities than other records. Indeed, we have found that communities react to these increasing forgetting rates by including more and more important documents in their cultural memory. Summarizing, the excess of information promotes higher forgetting rates, but knowledge communities, physicists and high inventors here, react to this by better filtering useful information for them. And finally, and motivated by the real world effects that focusing the collective attention in a particular topic has, we investigated the role of online content moralization on collective attention. We used data on more than 2 million posts from Twitter, Reddit, and Asian, which was an anonymous, a popular right-wing extremist forum. We quantified content engagement as the number of retweets in Twitter and as the number of replies in Reddit and Asian. We also measured different confounders for engagement, such as the text length, if the text has a URL, if the text has some media content, the number of followers of the author, and if the author of the content has the account verified. These both are for Twitter, particularly. And then to quantify the content moralization, we use linguistic inquiry and word counting to detect moral words reported in the Moral Foundation Dictionary. For each online text, we know that also we replicate our content moralization measure using a word embedding approach. Empirical literature suggests an unbounded positive effect of content moralization. And theoretical literature suggests also a penalization in the overuse of moral content. What we found in the raw data, we found a positive but logarithmic effect of the number of moral words on content engagement and a negative and exponential effect of the ratio of moral words on content engagement. Then we bring our data to a negative binomial regression models, and we found that both effects survive after controlling for all the available confounders. In average, the alpha exponent of the number of moral words is 0.45, which means that a change of the 10% of moral words in a given text leads approximately to a 4.5% increasing in engagement. Also, in average, the exponential decay parameter gamma is minus 2.42. For example, in Reddit here, where the aggregated coefficient of the range of moral words is gamma, it's equal to -1. Therefore, a 5-fold increase, ceteris paribus, in the ratio of moral words, for instance, a change from 5% to a 25% of moral words in the text would result in an 18% reduction in content engagement. Finally, from our model that integrates the positive effect of content moralization and the penalization of the overuse of moral language, we derive an interesting property, a point in which moralization maximizes online content engagement. In average, across all the topics, the optimum moral engagement is 22.2%, which means that generate online content with a 20% of moral loading maximizes people's engagement. Therefore, it could extend the time at which collective attention is focused on a certain topic. In other words, and coming back again to the minors example, the optimum moral engagement could have contributed to foster collective action. Well, these have been some of the ongoing research projects that we are developing in the southest country in this work on collective intelligence. We have shown that we can build tools for collective intelligence and make them available to the public, and thus contribute to improve individual outcomes such as university program selection, and provide insights for improving cooperation in elementary schools. Also, we have studied types of collective intelligence in education and citizen participation, showing that cooperation and coordination can emerge under certain conditions and improve groups and individual outcomes. Finally, we are contributing to the understanding of collective attention dynamics, which serves as a catalyzer for collective action using a novel approach fully grounded on collective memory mechanisms. Of course, all of these research projects are possible because of the collaboration with several students and researchers from different parts of the globe. Also, thanks to the collaboration with different institutions and companies in Chile and around the world. So that's it. Thank you very much for your attention.
Thank you. Thank you. Thank you very much, Cristian. That was like 3 separate presentations or more rolled up into one. Really fascinating work. Thank you so very much. And I think that we're joined in the panel by your collaborators. We're joined by your collaborators, Flavio Pinheiro and Carlos Rodriguez. So welcome. We do have a question, and please put those questions in the Q&A box. We'll start perhaps with one question from somebody who you may be familiar with, Cristian. Luis Amaral has asked a question about the whether you had any problems in getting IRB approval for the study with children.
Okay, yeah, that's a very good question, because at the moment we run the experiments, we had to be very careful with all of the commands that the ethics committees decided for this experiment. It was hard, but we were able to collaborate with an educational institution in Chile, a community of different schools, and they managed to ask for the informed consent with the parents, and also we managed to work with the data in preserving the privacy of individuals at that point. Also,
that's great. So,
maybe, sorry?
please go ahead.
Maybe Carlos also can complement this question because we work together on that part.
Well, it's exactly what Cristian was saying. It was very important for us to work with one of the councils from Santiago, from our capital in San Bernardo. So sometimes schools are a bit skeptical about these things. They are over-intervened with a lot of surveys, and I think that this aggregation, this association of schools like that belong to this community with this institutional instance helped us to break those barriers and allow us to get all the necessary permissions and everything.
Was there a difference between the process? I think you said that there was data from both Chile and Portugal.
But that's another study. Yeah.
That's another study, and that was with applicants. So what we did there was we managed to get the data in Chile, at least, using a government instance. In Chile, we have, I don't know how to say it, it's like a plan or something that allow people to ask for information to the central government for a law called transparency. So every single people in Chile can ask for information, right? And they manage to deliver it in an anonymous way, right? And then when we run all of the pilots, like the proof of concepts and all of these things, then we sign an agreement with the Ministry of Education to further extend this project, and there we were able to get even more data, and also, of course, accomplishing all of the mandatory regulations in terms of data protecting and privacy of people. And for Portugal, well, Flavio, we're working with Flavio with the data from Portugal, so I think he could provide more details in that process.
Yeah, so the Portuguese data was obtained through a collaboration for a project, so it spans a much shorter time window. But yeah, I think the advantage of Chile and Portugal is that we have a centralized system for applications to higher education. So when students apply, they have to list a set of preferences of degree programs they want to study. Okay, and so in Portugal we got the data from it was highly anonymized. That was for some analysis it was a problem for the Portuguese data. That wasn't so much for Chilean data, but it was through a collaboration. They basically gave us like a dump that listed the preferences of each applicant, not higher education, but the secondary school scores and so on and so forth. Yeah.
Excellent. There is a interest also in the last experiment the last research you were talking about with the Twitter and Reddit. And would you mind putting up those slides again? Because you spoke very interesting about the different words and the increase in the moral words and how that changed the retweeting. But I was wondering if you could go back to that slide and talk to that just a little bit more. I think there's a lot of interest in that section.
Here?
Yes.
So, well, what we did here was we gathered data from these 3 different social networks or social platforms, and we detect moral words for individual posts. Okay, so we use different methodologies such as linguistic inquiry and word counting, word embeddings, in particular word to vec, right? And the moral foundations dictionary. So we took this moral foundation dictionary, which is already validated, right? And we detect all of the modal words that are in every single text. Then what we do is basically we took this data to a negative binomial regression model, just because the dependent variable, the engagement is a counting variable. So we measure it as the retweets and replies. So using negative binomial regression models, and all of the confounded variables that we had available for this study. And we found first that the moralization, it means the number of modal words in a certain text is positively associated with content engagement, which is in line with previous empirical literature, but with slightly different, right? Because the model that they use, or the dependence of these two variables, is completely different, but still is a positive relationship. However, on the other hand, theoretical literature at that point suggested that it should be a penalization or a negative effect for the overuse of moral language. So we proposed the simplest metric to quantify the overuse, and that was the ratio of moral words in a given text. So basically the number of moral words divided by the total number of words. So we found there that, in this slide, that first, a negative effect on the ratio of moral words with content engagement, and also the functional form of this negative effect is exponential. So now we have, empirically speaking, these two effects, right? The logarithmic growth and an exponential decay competing, right, in the moralization of online content. So our model also predicts an optimum, right?
Right.
Mathematically speaking. Okay, so we compute that optimum, which is basically the ratio between the two parameters. Okay, and we compute the optimum for every single topic that we analyze in these three different platforms. So the meta average of all of these topics is 22.2%, which means that, at least mathematically speaking, this point should maximize the effect of moralization in content engagement. So that is pretty much the study.
That's great. I appreciate it, and interesting to see there's a couple of outliers there. Adam Pa has a question for you, Christian. For the social engagement research, would you say that this also suggests skill on the part of an individual poster? Or is it just that highly charged posts create more engagement? Good question.
I'm not sure if I understand the skill part, but I think that yeah.
I think, and maybe I think we can possibly unmute Adam, Megan, or Andy if that's possible. But the way I read the question, Christian, does the engagement suggest kind of intention on the part of the poster? Or is it just, the use of those moral words will, and please jump in, Adam, if I'm not expressing that correctly.
I see. Thank you for the clarification. Yeah, well.
No, you nailed it.
With the, in this study, we cannot determine if this kind of like pattern it's explained by the skill of the posters, or it just because some topics value or penalize moralization in different ways, right? The only thing that we can say here for sure is that basically there are these two effects that compete in a given text for engagement, and mathematically speaking, it should be an optimum point in which this effect is maximized. But with the data that we have, we cannot yet reply the question if this is because the poster actively decide, right, where or how moral is the content gonna be, or if just because given the context, circumstances, the platform, moralization is more or less valuable for certain text. So I don't know if that replies the question, answer the question.
I think so. I think Adam would jump in if it didn't. Perhaps with just a couple of minutes left, Christian, I might ask you and your collaborators, you know, what's next on this, all of these different projects? What are you most excited about? What do you think has the most potential for great impact in these different lines of your research?
Okay, well, in my case, I have two things on the pipe, right? One is kind of like improving or create more tools to the public for collective intelligence, right? And go deeper on the understanding on collective intelligence, but in specific communities, like a more territorial work to provide or to have more impact in real people, right? That is one of my goals. And the second one is more related on how collective intelligence can be augmented by artificial intelligence. So in that sense, that's kind of like a midterm goal. I would like to go further on the relationship first between how people process information and interact with the process of information, and how artificial intelligence can be useful for augmenting people's collective intelligence. So I think that to me at least is kind of like the path that I want to follow.
Yeah, very interesting.
May I add something that I think that is like a very nice thing about Christian's approach to science, and also his interest in social impact, is that if you take, for example, the higher education space article that they wrote with Flavio and published in EPJ Data Science, that was the basis for the creation of this platform that uses like all the previous the collective intelligence embedded in all the previous applicants to this to higher education in Chile. But at the same time, once you have this platform, you can also start recollecting additional information from all of the users and further understand the decision and what are the determinants of the decision of a particular career path, like after secondary school in higher education. So I think that this interplay between social impact and research advance that you can find in Christian work is a very nice model for combining these two aspects of our academic life.
Excellent. Thank you, Carlos. I think, Flavio, did you want to add something there?
No, it's fine. If you don't have time, we can close.
Oh, no, it's fine, please. Or I can, there's one more question I could ask from.
Go for the question.
Okay. This is from Luis. on the project about community discussions about priorities for constitutional change. Are you able to correct quality of contribution by educational level of speaker? I'm thinking that people with lower educational level may be less able to frame their arguments as effectively, even if their thinking is of high quality.
Yeah, that's a very good question, because this is exactly right. I mean, we found, for instance, and I showed that the higher quality texts are produced mainly by cities with a higher development index, right? And this index has a strong component of education. Also, we found that one of the determinants in citizen participation was the level of education. So what we are trying to do now, given the access that we have to this data, because with the data that we have was the entire data set, but we had to run all of the analysis at the level of cities, because we didn't have more information at the individual level. So what we are trying to do now is get individual level data to exactly complement and trying to answer empirically this question. But what we think about that is basically the design is very important in these kind of instances. So we should be able to mix people to first to control for these determinants of participations, right? That in some sense they generate some biases regarding education, technology access, and so on. And in order to do that, right, the design is key. I mean, we should be able to, for future processes like this, to be able to mix people with different types of knowledge, also with territorial necessities, in order to have both components, right? For one hand, you are going to be able to generate good conclusions or good arguments and good, in the best case, solutions, propose good solutions, but also you are going to be able to leverage all of the problems or issues that people have in their territory. So we need to design this kind of instances in that way, in the way that we maximizes the outcome given these two different variables.
Wow, thank you very much, Christian. Thank you, team. Thank you, Carlos and Flavio. Thank you to our wonderful audience and participants. This was a very dynamic conversation, and lots, like I said, many different research aspects put into one. So thank you so much, Christian, and lovely to have you back at NICO, and Flavio and Carlos, nice to have you join us as well. Thanks so much, everybody. And particularly our speakers, we look forward to seeing you all again next week. Thank you, Flav. Thank you, Christian.
Thank you very much for having me.
Hi.
This is the first time you guys had two Christian candidates in this session.
Right.
Okay, bye.